class, I wanted to make another video showing an example from a homework type of problem where you're asked to solve a system of linear equations using matrices and Gauss-Jordan elimination. So whenever I see Gauss-Jordan, notice that this is asking us to use an augmented matrix and row operations to transform not just a matrix into REF form, but our goal should actually be RREF form, reduced row echelon form, which again means, yes, I need ones along the diagonal, of course. Yes, I need zeros below the diagonal, of course. But instead of stopping there, like I would with REF, I would now need to come back afterward and get zeros here and zeros here. So zeros above and below. And the beauty of RREF, especially if you're using technology like a TI calculator to see the solution right away, is that here you know 1x equals this number, 1y equals this number, 1z equals this number. So the solution is very clear to the reader right away. But it does take three extra steps typically after you get the ones on the diagonal and the zeros below to come back up, get 0, 0, and 1 here. So let's begin by rewriting our system of linear equations as an augmented matrix. So our first row would be 1, negative 1, 0, 1. Simply copying the coefficients of the first row. The coefficients for the second row are 1, 0, negative 1, negative 2. Again, watch my signs carefully. If I make a mistake, we're toast. All right, let's look at row 3. The coefficients here, 4, 1, negative 1, 3. Make sure I copied those right. All right. So once I have my augmented matrix representing my system of linear equations here, I will now proceed to inventory what I have and what am I legally allowed to do in order to rewrite it as reduced row echelon form, or RREF. So the first thing I notice, happily, is that I already have a 1 in the first row, first column entry 1, 1. So that's great news. Now you might be tempted to get a 0 next to it because that's ultimately what we need here, but the order of operations here is typically to go below and get a 0 next. So I would typically like to come down here below and get a 0. So you can't multiply by 0, but remember what we can do? We can multiply a row by a number and add it to another row, or another multiple of a row. So what I could do here is I could notice that if one of these was a negative 1 and one of these was a positive 1, they would cancel out, wouldn't they? So I could do, for example, row 1 plus the opposite of row 2, or vice versa. In other words, I could subtract the rows, which is the same as adding a row plus the opposite of a row. So it's easier to say subtract the row here. So one thing you want to notice is what you would like to end up happening to save you a step. Yes, I could do row 1 minus row 2 and get a 0 here, but wouldn't that also mean negative 1 minus 0 is negative 1? And I'd like to end up with a 1 here, not a negative 1. So if I'm a little clever, I can save a step if I do row 2 minus row 1, put that result into row 2. Now again, you don't have to be that clever, but if you see it, that saves you some steps sometimes, if you can think ahead of what the next step might be. Okay, so I'm going to recommend that you copy and paste your old rows and then only change the new rows, maybe in a different color. So the old rows were 1, negative 1, 0, 1 for row 1. And old row 3 was 4, 1, negative 1, 3. So only row 2 is really changing here after this row operation. Row 2 minus row 1. Let's try it. 1 minus 1 is 0, which is what I was after. 0 minus negative 1 is positive 1. So again, that's me thinking ahead so that I can get a positive and not a negative here. Then again, row 2 minus row 1. Negative 1 minus 0 is negative 1. Excuse me. And for this entry, negative 2 minus 1 is negative 3. So watch your arithmetic. Really easy to make an error here. Okay. So now I inventory again where I'm at, what I've done that I enjoy, and what I'd like to make different. So I notice here that I have the 0 that I wanted. And typically next I would come and try to make this entry a 1 by multiplying by the reciprocal if it was like a 2 or something. But it's already a 1, so I'm going to make note of that. And again, you might think, well, should I get the 0 next to it? No, after we get this 1, we typically come down here to get the 0. So let's come down here and try to create a 4 to become a 0. So how could I do that? Yeah, I can multiply row 1 by negative 4. Good job. So that's what I'm going to recommend here. Row 1 gets multiplied by negative 4, and then we add that to row 3, putting the result in row 3 to get our new version of this augmented matrix. That means the same thing, but looks more helpful. So I'm going to copy and paste the old row 1 and the old row 2. 1, -1, 0, 1. Again, catch me if I make any mistakes. It can happen. Row 2, 0, 1, -1, -3. Okay. Now in row 3, that will become the new row after this row operation. -4 times 1 from row 1 is -4. Plus 4 from row 3. -4 plus 4 is 0. That's what I wanted. -4 times -1 is +4. +4 plus +1 is +5. Okay, that's interesting. You might be a little sad there, but that's okay. That might work to our advantage, we'll see. -4 times 0 is 0. 0 plus -1 is -1. And again, -4 times 1 here is -4. -4 plus 3 is -1. So watch your arithmetic very carefully. So let's inventory where we're at. So we notice here that we have our 0. We turn that 4 into a 0. That's what we wanted. And now our next step is typically to turn that 5 into a 0. That's right. So how could I do that? Well, I can't multiply a row by 0 because that kills off an entire equation. Instead, I need to multiply either row 1 or row 2 by a number so that when I add it with row 3, the 5 goes away, becomes 0. So what do you recommend? Should I use row 1 or should I use row 2? Yeah, I'd want to use row 2 because using row 1 would change my 0, wouldn't it? So we're going to use row 2 here. What could I multiply row 2 by in order to turn this 5 into a 0? If you said -5, you'd be correct. So we're going to do -5 times row 2 added to row 3 and put that new result in row 3. So let's rewrite this matrix again in an alternate form that's helpful to us, but means the same thing. So let's copy and paste rows 1 and 2 since they are unchanged in the end here. 1, -1, 0, 1. 0, 1, -1, -3. Again, watch me carefully. In row 3 here, let's get our new entries. -5 times row 2, the old row 2, would be 0. 0 plus 0 is 0, which is good news. We don't want to unchange the good stuff that we already got. We don't want to change the good stuff we already got. Let's go to our next entry. -5 times 1 is -5. Plus 5, that's the 0 that we wanted. Great job. Let's do the next entry. Carefully, -5 times -1 is +5. +5 plus a -1 is really like saying 5 minus 1, which is +4. Our next entry is -5 times -3, which is 15, +15. Adding +15 with a -1 is really like saying 15 minus 1, which is +14. You might already see something cool. We almost have z, don't we? We almost know what z is because we really are one step away from REF form at this point if we were just doing Gaussian elimination. So let's go ahead and notice what this produces here. We have our 0 where we wanted it. That's our goal here. We got our 0. And our next step would be to get 4 to turn into a 1. And how could I turn 4 into a 1 without changing the zeros in front? That's right, multiply by its reciprocal. So 1/4, 1/4, times row 3, putting that result in row 3. Let's see what new augmented matrix we produce. That means the same thing, but is more helpful. Copying and pasting rows 1 and 2, we have 1, -1, 0, and 1 for row 1. We have 0, 1, -1, -3 for row 2. And the new row 3, after multiplying by its reciprocal, 4's reciprocal, which is 1/4, we get 0, 0, because multiplying anything by 0 stays the same. 1/4 times 4 is 1, because 4 over 4 is 1. 14 over 4, that reduces, doesn't it? They're both divisible by 2, the numerator and the denominator. So 7/2 if you like fractions, or you could say 3.5 if you prefer decimals. Okay, so now we have what we would consider row echelon form, or REF. That's helpful for solving. We already know what z equals. We now know this is a consistent system with one independent solution. If, on the other hand, you had a 0 equaling a number, all zeros equaling a number, that would be false. That would be inconsistent. If you had all zeros as well as this 7 halves is a 0, that would be consistent but with infinitely many dependent ordered triples. So in this case, we have one independent solution because z will equal 7 halves. So I could already go to my solution set, for example, noticing that I do have one independent solution for this consistent system. And I already know for the ordered triple what z is. Z is 3.5, or 7 over 2. Okay, so I already have that part. But I'm not going to stop there because they asked me to do this problem with Gauss-Jordan elimination, which means I need to continue to get zeros above the diagonal of ones. So the next step that we would typically employ would be to come back after we have our 1 at the end here and work on getting this entry to turn into a 0. Work on getting that 0 here. So how could I do that? Well, I can't multiply by 0, that would kill the whole row, but I can add multiples of rows together. So what do you recommend we do here? Well, yeah, if I multiplied row 1 and row 2, the 0 would not affect the 1, which is good, and we would get the 0 where we like it. So let's do just that. Let's add rows 1 and 2 together, putting the result in row 1. A lot of students get confused because they're not sure where they're putting their answers, but if you keep in mind what you're trying to do, that will guide the process of who stays the same and who changes. So I'm going to copy and paste the unchanged rows 2 and 3. 0, 1, -1, -3, 0, 0, 1, 7 over 2. But the new row 1 will be the result of adding the old rows 1 and 2 together. 1 plus 0 is 1. Good, we didn't want to change that. -1 plus 1 is 0. Good, that's what we wanted to happen. 0 plus -1 is -1. And 1 plus -3 is -2. Okay, let's take a look at what we have that's good for us and what needs to change a little bit more. We now have the 0 where we wanted it. So next, after we get that 0, we usually go to the right and try to get that entry to be 0 as well. So what rows could I add together to make that happen? Or do I need to multiply a row by a number first? That could happen too. Well, I notice here that I would not want to use row 2, would I? If I add row 2 to row 1, I would change my 0 that I just worked so hard for. So instead, I would like to use row 3 because I have 2 zeros here, so they won't affect these numbers. So yes, looking here, we're very lucky because if I add rows 1 and 3 together, row 1 plus row 3, and put that result in row 1, it's going to not change these two entries, but only the one we were interested in, as well as the constant there. So let's rewrite our augmented matrix in an alternative format that means the same thing, but is more useful to us. Copying and pasting carefully, rows 2 and 3. 0, 1, -1, -3. 0, 0, 1, 7 halves. Okay, so getting my new row 1 here, that's found by adding rows 1 and 3 from the previous step. 1 plus 0 is 1. 0 plus 0 is 0. Excellent. -1 plus 1, there's the 0 I wanted. Now watch your fractions here. You can use a calculator if you need to. -2 plus 7 halves. Well, -2 could be written as something over 2, couldn't it? How about -4 over 2? Wouldn't that mean the same thing? So -4 over 2, I'll just write it out for us. That's what -2 means. Plus a 7 over 2 creates what number? If you said +3 halves or 1.5, you'd be correct. So that's the entry that we have there, 3 halves or 1.5. Let me erase that real fast, give some space. Okay, so we are almost done with reduced row echelon form. Taking a look carefully at what's left, we just got our 0 here, which is what we wanted. And after we get that 0 there, we go right below it to get a 0 below. So how can we make that -1 turn into a 0? Again, we can't multiply the row by 0 because that kills the entire row. But we could add it with row 3, and that would unchange these two entries, but it would change the one we're interested in. So let's do that final step here. So our final step would be to take row 2, adding it to row 3, putting the result in row 2, and see what we get. So if I do that, I'm going to unchange in the end. I'm keeping rows 1 and 3 unchanged, so let's do some copying and pasting. 1, 0, 0, 3 halves. Again, row 3 is unchanged. 0, 0, 1, 7 halves. But to get our new row 2, we add our old rows 2 and 3 together. 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1, that's the 0 we were after. Hey, this looks like reduced row echelon form, or RREF. 1's on the diagonal, 0's everywhere else before the constants. But let's get the most important part here, which is what happens when I combine rows 2 and 3 by addition and put them in row 2. So that'd be negative 3 plus 7 halves. Well, negative 3, how could I write that as something over 2? Wouldn't that be negative 6 over 2? That's really the same as negative 3, isn't it? Plus 7 over 2. What does that consolidate into? Positive 1 over 2? Is that what you're getting? 0.5. So 1/2 is what we get for that entry right there. Okay, so now since we are in reduced row echelon form, we technically can read off our solution completely, because this whole equation just says 1x equals 3 halves, 1y equals 1/2, and 1z equals 7 halves. So again, 1x, no y, no z. 1y, no x, no z. 1z, no x, no y. And that's how you can read off your solutions for x, y, and z. So our solution set for this consistent, independent system is the order triple, 3 halves, 1/2, and 7 halves in braces here. So I hope that was helpful for you. If you have any questions, please don't hesitate to reach out by email or phone. Otherwise, happy practicing, because remember, math is not a spectator sport. I'll see you next time.